We will discuss the mole concept in this video and we will practice some mole conversion questions. So to begin with, what is a mole? A mole is a unit used in chemistry, just like a pair is 2, a dozen is 12. A mole is 6.02 times 10 to the power 23 particle. This number is called Avogadro's number as a respect to the scientist who introduced the mole concept. Okay. And a mole consists of representative particle. What is that means is a representative particle is the type of particle that a substance is usually composed of. That can be atoms or ions or molecules. Okay, so this mole serves as a bridge between the microscopic scale to the macroscopic scale because scientists cannot work with tiny particles. Atoms are very microscopic, right? So scientists cannot work with atoms in the laboratory. So mole serves as a bridge between molecular scale to the real world scale. Okay, mass of 1 mole of the substance, we call that as molar mass. And you can get the molar mass of elements from the periodic table. Say for example, if you look in the periodic table, when you round it for carbon, it is 12, and for sulfur, it is 32. All right, and but for compounds we may have to add the atomic masses to get the molar mass of that compound. Let us see how to find the number of moles. So if you are writing just the symbol, say for example for lead, if you look in the periodic table we can see that lead is Pb, correct? So if you just write the symbol, we read it as 1 mole. Okay, so that is 1 mole of lead. And if there is a coefficient in front of it, if there is no coefficient, that means by default it is 1. But if there is a coefficient in front of that symbol, we say that many moles. That means if we are writing 3 Pb, we will say 3 moles of lead. And if you are writing 4.5 Cl negative 1, that represents 4.5 moles of chloride ions. Okay, and then if there is a compound written like this, and if there is a coefficient, we say that 2 goes for calcium and that 2 goes for chloride ions as well. And there is a 2 here, right? So 2 times 2, this one will be 4, and for calcium it's going to be 2. So we can say that 2 moles of calcium chloride, and we can also say that 2 moles of calcium ions because it's a compound. So 2 moles of calcium ion and 4 moles of chloride ions. Okay, that's how we will decide how many moles are there if we have an element symbol written or a compound is written. Okay. Now, if we are given mass of a substance and we want to convert to moles, use the formula moles equal mass divided by molar mass. So how to find the molar mass? For elements, the atomic mass from the periodic table is the molar mass. No need of any calculation. But for compounds, we have to add the atomic masses of each element. Let us see an example to calculate the number of moles in a specific mass of a sample. Suppose we have 27 grams of aluminum. What is the number of moles present in 27 grams? Substitute in the formula which is moles equal mass over molar mass. Since this is an element, we can find the molar mass from the periodic table by looking at the atomic mass. For aluminum, it is 27. So 27 divided by 27 equal 1 mole. And there is another method called dimensional analysis that you can see in most of the college textbooks. And also in college, most of the professors use the dimensional analysis. So in dimensional analysis, start with what is given. So we have 27 grams of aluminum given. So 27 grams of aluminum we wrote. And write what is asked after the equal sign. So equal to, they're asking find the number of moles. So we can write moles here. And then write the conversion factor so that
the unit will cancel each other, leaving the required unit. So I need mole in the answer. So I will write mole on the top, and I want to cancel grams of aluminum. So I will write grams of aluminum in the denominator. So each 1 mole of aluminum has 27 grams of aluminum. So grams of aluminum and grams of aluminum will cancel each other, and then you will get 27 times 1 mole divided by 27 grams, which equals 1 mole. Let us see another example to calculate the number of moles in a specific mass of a compound. Suppose we have 36 grams of water. What is the number of moles present in this sample? Substitute in the formula moles equal mass divided by molar mass. Since this is a compound, we can find the molar mass by adding the atomic masses. Get the atomic mass from the periodic table, then add them up. For water, we already calculated as 18 in the previous calculation. So we just have to substitute now 36 divided by 18, which equals 2 moles of water. And now using the dimensional analysis, start with what is given. We have 36 grams of water given. So I will write 36 grams of water. And what is asked? After equal sign, I will write moles because that is what we are supposed to calculate. And now I want to cancel the grams of water, and I know the relation. In 1 mole of water, we have 18 grams of water. So grams of water and grams of water cancels out. And what are the things left? 36 times 1 mole of water divided by 18. That will give you 2 moles. See, the answer is same. So whichever way you feel comfortable, go through that way, and both are acceptable. To find the number of particles, just multiply the moles with Avogadro number, which is 6.02 times 10 to the power 23. For example, to find the number of aluminum atom in 1 mole, what we will do? We will just multiply 1 mole by Avogadro number 6.02 times 10 to the power 23. So that means 1 mole of aluminum has 6.02 times 10 to the power 23. It should be power. So mass to particle conversion. To find the number of particles from the given mass, first find the number of moles and then multiply with Avogadro number. Now, using dimensional analysis, we can see that this is a two-step problem. First, convert the mass to mole using conversion factor. 1 mole of aluminum contains 27 grams of aluminum. Next conversion factor is from moles to particle, which is 1 mole contains Avogadro number of particles, which is 6.02 times 10 to the power 23. And now cross out the same unit and then multiply that numerator and then divide by denominator. You will get the answer. Okay, let's cancel that one out, cancel this one out, and your answer will be 6.02 times 10 to the power 23. 23 here. This roadmap helps to avoid confusion whether to divide or multiply for the respective conversions. If the number of particles are given and want to convert to mole, divide by Avogadro number. Divide by Avogadro number will give you moles. And if you have moles and you want to get the mass, you just have to multiply by molar mass. And now backward. If you have mass and if you want to find moles, mass divided by molar mass will give you moles. And now if you have moles and if you want to find the particles, moles multiplied by Avogadro number will give you the particles. What if you want to convert these mass to particles and particles to mass, two-step. Go through moles. Okay, so first convert particles to moles and then mass, and vice versa here. Go back, mass to moles and then particles. So if it is like this, two-step problem. If it is one jump, one-step problem. So mole conversion summary is, mole is a unit of measurement in chemistry. 1 mole of any substance contains 6.02 times 10 to the power 23 particles. Particles means it can be atoms, ions, or molecules. The chemical formula represents a mole of that substance. The molar mass expressed in grams represent the mass of 1 mole of that substance. Okay, move to the next lesson.